So here we have our photo plot marked out onto our tracing paper. So I've assembled the top view and the bottom view onto two separate sheets of tracing paper. The tracing paper, as you can see, I've put together so that the most opaque sides are together to each other, so that they are laid flat on the board. So looking through it, you can see the bottom and the top views of what we are going to effectively expose using the UV lamp box. That is what I'll describe next. So here is the homemade exposure unit. So we've got 4 tubes mounted inside this frame. It's pretty rough and ready put together type frame for exposing the PCBs. Tubes are Sylvania Blacklight 350s, and there are 8 watt BL 350s, and so there's 4 of those. And I've put the chokes basically in the bottom there, just to, the ballast in the bottom there, just to hide them out of the way underneath. The box itself is, as you can see here, with a clear piece of glass on top for exposing the PCBs, a lid, and then a bit of sponge which lays on top of the PCB. So here is the board put between the tracing paper, and you can see that I've just held them in place top and bottom with a piece of sellotape onto the board that's clear of the actual area that you need to etch. So we're going to expose it for 1 minute and 50 seconds each side. So board loaded on the table, roughly in about the middle will do nicely, and we put our piece of foam over the top. The idea of that is that we push down from the top and literally flatten it against the glass to try and keep it as opaque as we possibly can. So what I'm doing now is mixing up some of the developer. This is a bit ancient, this developer actually, but it's still alive and kicking, so it's still okay to carry on using. Now I mix it up at 18:1 strength. Now it says 9:1 on the bottle, but I found that it just strips it off just too quickly, and it doesn't develop properly. So here is my bowl made up, ready for my solution to go in it. Now the important thing here is, and throughout this whole exercise, is to wear gloves, wear rubber gloves. Don't get your hands in the mixture because it'll just ruin it. So let's just attempt this and see what if we can see the image coming through. So here's my board going into the mix, and now what we do now is we gently rock it to see whether we can see whether it's a good image coming through on this. So you can normally see it, the developer starts to change colour, and you will start to see a kind of magenta looking colour as it comes off the board, and then you can start to make out the tracks that start to come through. So you can see that the developer is washing away all the areas that have been exposed. And as I say, if you want to do more boards here, the key thing here is to remember to always wear gloves, and just turn the board over in the solution. You can see in the back, on the back view now, we've kind of got something which is coming through. So there you are. You see it's you see the developer has changed into a sort of a, it's got a magenta hue to it now, where it's taken off the old photoresist that's been burnt away by the UV lamp. And what we're looking for really on the developer side is a nice contrast in the tracks, so that you can see that all the original etch resist has been removed in the places where we need to remove it. So that's that bit kind of done. What we're going to use now is we're going to use some of this stuff, the old ferric chloride. So this is 40% mix here, and I bought 5 litres of it, so it'll probably keep me going the rest of my life. But this stuff is nasty, so it's nasty to copper. It's not too bad for everything else, but it obviously eats copper. So you should really try and keep it away from your copper pipes, or you probably won't have much left of them. So yeah, I'm going to knock this up to about a 30% mix. Usually find that 30% kind of does it, but you can experiment to see how quick you can do it if you do it neat, I suppose. But the other thing to bear in mind is that there is an optimum temperature for this, and it's around about 23-24 degrees C. What I normally do is I normally boil a kettle and I say don't do this in your sink at home. This is not good. So you need to have a hideaway sink, as you can see from the state of it. It does clean up okay, but this stuff eats everything, so be careful with it. So let's mix up our mix, put the 2 boards in. I use a little bit of hot water, not boiling, but hot water into the mix, just to bring the temperature up a bit. It just speeds things up a bit, but let's see what happens. So here is the completed board from my original tracing paper. So the tracing paper, double-sided tracing paper, and then of course we just expose both sides to get you your final copper track print onto the board. So obviously I've removed all the old copper that had been exposed to the UV lamp, and the stuff that hadn't obviously has stayed on there, which you hopefully want. So this was obviously it was printed on a laser printer. It was a standard Samsung laser printer. But your biggest problem with doing these type of prints is trying to get some vertical edges that haven't been eaten away, where the UV gets underneath the opaqueness of the track. But for this size tracks, I mean, these are greater than 25 thou, and you're up to 50 thou or more. It's not a problem with this. It's quite simple to do. When you get to very, very fine tracks, then of course you're in a different league. And the best thing to do there is probably prototype, get different sections to work, and then redesign it with your favourite CAD PCB software, and once you know it works, then start to squeeze it down in size. But this one, which is actually an intermediate board for the Triac circuit, which I describe elsewhere,